Hey, everybody. I wanted to make sure I addressed a really good question that I got from one of you in D Block regarding why we don't add standard deviations. Why are we allowed to add variances, but not allowed to add standard deviations? So you might remember we watched a video last week, this week. I can't even remember when. All the snow days and everything are getting me totally thrown off. But we did watch a video with Penny, the very dry Penny from Austin, Texas, where she did actually give us a really critical piece of information, which is this. So we can add variances, but we never add standard deviations. And that's actually really critical, especially in this particular chapter where we're talking about combining random variables, right? So I kind of want to pull back for a second and let's remove ourselves from the realm of statistics and let's go back to geometry, all right? So adding variances is often likened to the Pythagorean theorem of statistics. So let's go back and talk about the Pythagorean theorem first. So the Pythagorean theorem tells us that if we have a right triangle with side lengths A, B, and C, we actually know that we can sum the squares of the legs and it will equal the square of the hypotenuse. A squared plus B squared equals C squared, all right? That is a geometric truth and it was proven by Pythagoras. Okay, that is a truth. Here is what is not true though, right? And this is what you should have learned when we covered the Pythagorean theorem. Derek is crawling on the floor. I'm not sure why. Maybe because he didn't want to be in the video. So here's what is not true. We cannot simply take the square root, take the square root, take the square root, and say then A plus B equals C. That is not true at all. A plus B does not equal C, all right? And let's use an example of this, a 3, 4, 5 right triangle, right? So let's say that A is 3, B is 4, and C is 5. Well, we can clearly see that by the Pythagorean theorem, 3 squared plus 4 squared equals 5 squared, because 9 plus 16 is in fact 25. But here's what is not true. A plus B does not equal C. 3 plus 4 does not equal 5, okay? And so you might be thinking, okay, well, this is great. This is all the stuff we learned in geometry, but how does this apply to variances and standard deviations, okay? So here's what I need you to consider. I'm going to erase these square roots for a second. This statement, that's a truth, right? A squared plus B squared equals C squared. That does not mean, though, that A plus B equals C. That is false. And now let's liken this to variances and standard deviations. All right, so I'm going to pull up another slide here. In order for us to understand the connection between the Pythagorean theorem and the current chapter, we need to talk about how do variance and standard deviations relate to each other. So for example, let's say I have a random variable x. That random variable has an expected value of mu sub x. That is its expected value, which is essentially its mean. It also has a standard deviation, sigma sub x. Standard deviation. Okay. How does standard deviation relate to variance? Because this random variable also has variance. I can square the standard deviation, and that will give me the variance of that random variable x. Okay, now think about this. We are squaring a quantity. And this is similar to what we saw with the Pythagorean theorem. The Pythagorean theorem told us that a squared plus b squared equals c squared. However, that does not imply that a plus b equals c. Now we have the same thing happening here when we are combining two random variables. All right, when we're combining two random variables, we know that we are allowed to add their variances to get the variance of the combination. Okay, so what do I mean by that? I mean that we can take the variance of some random variable x, add to it the variance of random variable y, and that will equal the variance of the combination of the two variables. This right here, this is essentially the parallel of the Pythagorean theorem. And why is that? Well, let's talk about the notation here. The variance of x could be rewritten like this. The standard deviation of x squared plus the standard deviation of y squared equals the standard deviation of the combination squared. There's your Pythagorean theorem. It's basically a squared plus b squared equals c squared. We are adding variance. We are adding the variance of y plus the variance, we are adding the variance of x plus the variance of y to get the variance of the combinations. That is a legal move. What is an illegal move? Well, we know from the Pythagorean theorem that a plus b does not equal c. I cannot add the two legs to get the hypotenuse. And the parallel to that in statistics is this. We cannot say that the standard deviation of x plus the standard deviation of y is equal to the standard deviation of the combination. That is simply not true. And that is why we do not add standard deviations, but we do add variances. And so you might be thinking, okay, well, where would I have seen this in some content that we've been covering recently? And here's where we have been seeing it. It's actually in the eating habits worksheet. And I do want to point something out here. At the top of the first page, you were given information about adding random variables x and y. You were given information about subtracting random variables x and y. And notice here, if x and y are independent, we can get the variance of the combination by adding the variance of x and y together. And likewise, even when you're subtracting, if x and y are independent, we can get the variance of the subtraction of those two random variables also by adding, okay? Now go look at the second page, because this is where this question even came from in the first place. Number 10. Okay, we are told the standard deviation of this random variable, the number of bacon McDoubles that Bailey purchases every time they make a trip to McDonald's. The standard deviation was, I believe, what was it? 0.31? 0.31, something like that. Yep, right up here, 0.31. Okay. The math here is not just adding 0.31 plus 0.31 plus 0.31. I'm not going to add it up 7 times. Why is that? Because I don't add standard deviations. I cannot add standard deviations. I can add variances. So what I want to be doing is taking the given standard deviation of 0.31. I want to square it. And then that quantity, I'm going to add that up 7 times, or essentially take that squared quantity and multiply it by 7. That gives me a variance. So this right here is 0.6727. That's the variance of the number of sandwiches eaten over the course of 7 days. But you weren't asked to give the variance. You were asked to give the standard deviation. So there is an additional step here. You have to take this variance back to a standard deviation by taking the square root, right? We know that there's a relationship between variance and standard deviation. If I square standard deviation, I get variance. I can take variance back to standard deviation by taking a square root, and that's how we're getting 0.8202 sandwiches as the standard deviation across those 7 days. So I just wanted to point that out and make sure that I got to make a video on this. I hope that this was clear. And I'll see y'all in class pretty soon. Bye.